Alright, so the first thing we're going to talk about today is setting drip rates and basically fluid over time.
Okay.
Okay? So, when we talk about fluid over time, there's a couple things that you need to know. Alright? The first thing you need to know is your drop set. Okay? What kind of drop sets do we have out there?
Micro, macro. 60.
Okay, what's the difference between a micro and a macro?
What's the 10 is for trauma.
Is that a micro or a macro?
It's a macro.
Huh?
It's the mac. This is the amount we drop per minute.
Okay. So micro drip set, we think of 60, right? And usually we think about this when we think about medical patients.
Yeah.
Okay? However, I will throw in this caveat.
Right.
Unless you're measuring a precise amount of fluid, like if you're doing a pediatric drip or something like that, or you want to dopamine over time, that kind of thing, and you want to measure it really precisely, it really doesn't matter. Okay? Because I can deliver the same amount of fluid fast with a 60 drop set as I can with a 10 drop set. Okay? It just takes a little more effort. Okay? We got to have some pressure behind the bag, that kind of thing. Okay? So what would a macro drop set be then?
For trauma, 20.
Okay, you think more of trauma. Okay?
You got 10 drops.
10 drop set, 15 drop set, 20 drop set. Okay?
I've never seen a 15 or 20. Oh.
So, well, they have them individually, and remind me, I'll show you all later. Okay, you can get them individually, okay, or they have these sets that you can dial in, and it has 10, 15, and 60 on it. Okay. So one set could actually be both of these. Okay. But they don't use them much anymore because they're a little more expensive than a regular drop set. Okay. So when we go to fluid over time, all right, we want to figure out how much fluid we want to give over how much time, right? And that's how we figure out how many drops per minute we're going to give. Okay? Now remember, with a 60 drop set, okay, 60 drops is 1 cc or 1 ml, right? 10 drop set, 10 drops, 1 cc or ml. Same thing with 15 and 20. Okay? So, what's the difference between the drops on these?
Over time, you just get more drops per.
So, in a 60 drop set, okay, you've got your drip chamber here, right? And you've got a little needle here, right? The little needle is to reduce the size of the droplet, right? So, these are going to be little drops, right? And then your fluid chamber here, right? In a 10 drop set, you got this here, and the drops are bigger, okay? In fact, it'll be 6 times bigger in a 10 drop set than it is in a 60 drop set, okay? Because it takes 10 drops to make 1 ml, right?
Yeah.
Versus 60 drops to make 1 ml. Does that make sense?
Yes.
Okay, that's how we get the drop set size. Okay? So, if I want to give a fluid over an amount of time, just like everything else with med math and stuff, you got to set up an equation. Okay? So the equation for fluid over time, alright, is your volume times your drip factor which is your drop set. Okay? Over the time in minutes. Okay? Alright. So, when you're breaking this down, okay, we'll get to it in a few minutes, but you're breaking this down to the lowest denominator, right? This will be mLs, alright? This is your drop set, which changes depending on which set you're using. Time in minutes, okay? So, before you even start, okay, if they tell you to infuse something over 3 hours, right, you need to equate that to minutes, okay? 180 minutes, right? That's how you break it down. Does that make sense?
Yeah.
Alright. Volume, how much you want to give, right? We'll go with the easy example here. 500 mLs, okay? We're going to use a 10 drop set. Over, say we're going to give it over an hour, just 1 hour, okay? So 1 hour, 60 minutes, right?
Mm-hmm.
So you put 60 down here. Okay? Everybody get it so far? Okay, still recording, that's good. So I know how to edit this little piece out. Alright. So you got your equation set up now. Alright? So, what's top line? It's 500 times 10.
5,000.
5,000. Okay? 5,000 divided by 60. Okay? And if you use your phone or whatever, it should come out to about 83.3, somewhere around there. Okay? So, 83.3 drops per minute. Okay? Are we going to get that exact?
Nope.
Okay? So, if you were thinking about this, alright, if you're a medic sitting on the back of the truck, and you want to give 83.3 drops per minute, say you're going to have them for an hour, right? You want to make sure this fluid lasts till you get to the hospital or whatever. Okay? But you want it real close by the time you get there. Okay, you got a 500 ml bag set up there. Alright? So, because this is 83.3, we'll make it 83, as long as we get in that ballpark, right? This is going to be a little bit imprecise, okay? So how do I figure out how many drops I'm getting a minute? Okay? I have to watch this drip chamber here, okay? Remember, we're in a 10 drop set, right? So it's going to be the big one. So I have to sit there and watch it, okay, and time it for a minute, okay, and go 1, 2, 3, 4, 5. It should be a little bit more than 1 per second, right? Does that make sense? All right, because if I had 1 per second, that would give me 60 drops, right? So I want it a little bit faster than 1 per second. Okay? And you can sit there and watch it. If you want to get as close to this as possible, you watch it for a whole minute. Right? If your math skills are pretty good, you can watch it for 30 seconds. If I did it for 30 seconds, what would it be? How many drops in 30 seconds?
41.
150.
41.5.
Half
You get half of it, right?
Oh.
So about 41. drops in 30 seconds, right? What if I quartered it? 15 seconds.
Yeah.
Okay? Could be about 20, 21, right in that area, right? 20 drops every 15 seconds would give me 80 drops every minute. Does that make sense? You getting it? Okay. So that's the way we figure that out. Okay? So, the thing that we need to know, how much volume we're going to give, right? So you could call this dosage order, okay?
Okay.
Right? Times your grip factor, this is your drop set, and over what period of time we're going to give it in minutes. Okay? And then once you get that figured out, then you just got to watch the chamber and adjust it, adjust the flow rate, right? Till you get where you want to be. Okay? Now some things, it doesn't make sense. Okay? If you're trying to give a large volume, okay, I wouldn't want to give it in a 60 drop set. You can't count it. These drops are so small and so fast. What are the riders doing? Because we would have to, if you wanted to do this in a 60 drop set, you'd have to multiply this by 6. So it'd be 498 drops per minute. Can you count that fast?
Yeah.
I can't. Okay? But you may see it on a math question thing. Okay? It may say, you want to give 500 cc's in a 10 drop set and a 60 drop set in 60 minutes. What's the drip rate? Okay? You still have to be able to figure it out, even though it doesn't make sense where you're going to have 498 drops per minute in a 60 drop set. Okay? So let's change that up a little bit. What if you wanted to give it over 15 minutes? Okay? So I want to give the same amount of fluid in 15 minutes. Alright, how would I set that up, Ruth?
Put everything over 15.
So I'd go 500 ml
Times your 10 drop set.
times 10 drop set
Over 15 minutes.
over 15 minutes. Right?
Yeah.
So that's still going to give me the same 5,000 over 15 minutes. What's your answer going to be?
333.333. About 333.
333.3
Repeating.
drops per minute. Right? So in order to give that, even in this big drop set, what's probably going to happen is this is going to look like a continuous stream, right? And you're going to be putting some pressure behind the bag to give that. Okay? If you want to give a 250 ml bolus, right? Like we talked about giving to our hypovolemic patients and that kind of thing, right? We're going to push that in pretty rapid. Okay? So the drip chamber is going to look like a continuous drip. We can look at the bag, right? Say we got a 1,000 cc bag here, right? And it's going to say 100 here, 200, 300, 400, 500, 600, 700, 800, 900. They might have one figure up at the top. Okay? Then sometimes we just have to watch. and say, okay, we're gonna give a 250 ml bolus, right? We got our line started. And when the bag gets right there, we're gonna reevaluate. Does that make sense?
Yeah.
Alright. Justin, come up here to the bowl for me. We're gonna give 250 ml in a 10 drop set over 20 minutes. Alright, everybody do this on your paper, make sure he gets it right. Make sure you get it right.
So,
Okay.
are we allowed to have calculators?
No. So the question was, are we allowed to have calculators? On the bus, I'm sorry, on the ambulance, yes, you may have your calculator, you're gonna have your phone, whatever. However, would it behoove you to know how to do this in your head?
Yeah.
Absolutely. Okay. Do you want to take a trauma patient that's been bleeding all over the place, you put a tourniquet on, that kind of thing, and take your gloved, bloody hand and go swiping on your phone?
I double mine up.
Okay, so you're at 110 degrees in Atlanta with 90% humidity, and you got this bloody glove. You say, I'm going to take it off, do the calculation, and then I got to put another glove back on. How easily does that glove go back on? Oh, it does.
I have a medical app, hyperhidrosis. Trust me, she gets her hands like that quick.
Okay, so what'd you come up with?
That should be ripping.
125 drops per minute.
Alright, what else? What'd you get, Ruth?
125.
What'd you get?
Well, see, that's my thing.
What's your thing?
Well, first of all, I got 10, because after I divided the 200 into 10, I got 200 into 20, I got the 10.
Where are you getting
So where
200
you
from?
Yeah. Is that? Oh, it's 250. My bad, I'm sorry. That's probably why.
Alright, if you don't set up your equation right,
Yeah, okay, so yeah.
you're
Okay.
kind of messed up from the get-go.
Yeah. Okay.
Okay? So, the equation, you just have to memorize. Okay? Once you have the equation memorized, it's just a matter of plugging in numbers. Okay?
I got 83
83 what?
drops.
Okay, show me on the backboard how you did it.
So this would be like doctor's order would be giving a patient 250 mL.
Or if you were just giving fluid bolus, right? If you said, you don't necessarily need doctor's orders to give fluids, right? You got standing orders, you got protocols, that kind of thing. Hypovolemic patient, I'm going to give him 250 ml fluid bolus, right? And I want to give it pretty rapid over the next, 20 minutes between now and the hospital, right? So what kind of drop do I need? Okay, so that would give me 125 drops per minute, okay, which is pretty fast. It's gonna look like this, because 125 drops per minute is how many per second?
125 drops per minute per second is 1. Oh, say again?
How many drops per second is that?
125. 2 drops.
How did you get that?
Divided by 60.
Divided by 60, because we're breaking down the time, right?
125.
So 1 minute.
So a minute.
1 minute
6 seconds. Okay.
equals 60 seconds,
Okay.
right?
Right.
So if I got 125 drops per minute,
Right.
okay, that's 125 drops in 60 seconds,
Right.
all right? So I take the 125 divided by 60, okay, and I would get a little bit over
0.08.
.08
Uh,
drops per second.
okay.
Does that make sense?
Yeah, it does.
Okay, so if I was timing it,
Uh-huh.
right, and I wanted to time it by 30 seconds,
Uh-huh.
how many drops would that be?
Let's see, you do it, hold on. Double it.
You times it by 30, right? So 2 drops per second times 30
That
seconds
one.
would give me 60 drops, right? And I can double check that in my head because 125 drops per minute, half a minute is half of this,
30.
okay? So in actuality, it'd be 62.5 drops every 30 seconds. Okay? Okay, still got a question?
No, I'm good. The first and the second part is just the third one right here. I'm getting there. I'm getting there because I like the environment. I'm getting there.
What third part?
The part when we do the
I get the drops first, I guess.
Yeah. I'm good.
You need to sit over in the back. What else you get on with that? Cardiac.
I'll just put in a picture there, I hope. Okay, so now that we understand drip rate, alright, how do I do the Zoom thing?
There it is, look at that.
Oh, I know.
You know what it is. Thank you, sir. That's first in the book. It says 2 words.
Alright.
So question, when do we go on, when do we do the lower end? Because we're always using the 4.
Alright,
So why is it
Good
2
question.
long? Yeah.
alright. So, Rue asked, when do we use the lower end of the formula? Because we're talking about the Parkland Formula now. Alright, so Parkland Formula, I think they also call it the consensus formula in your book,
Yeah.
okay? I had never heard it called the consensus formula. I've always heard it called as Parkland Formula.
Right.
So I actually had spent some time trying to look up consensus formula and it wouldn't give me any results.
That was my objective question.
Okay, so Parkland Formula for burns, 2 to 4 mLs, right,
Yes.
per kilogram, okay, times
Total body surface area.
body surface area burned, right? Okay, and then that goes over 2, okay?
Those flashes are multiple times.
Yep. So, 2 to 4 mLs, okay? Depending on how serious the burn, how much body surface, it basically becomes a paramedic discretion, okay? Depending on your protocols now. Some protocols will just say straight up 4 mLs, right? But for the national standard, okay, where the most protocols and stuff come from, alright, it gives you a range, 2 to 4, okay, that leaves you a little bit of discretion. Medical directors and that kind of thing, they may say, hey, we're going to go the lower end first and then we'll pick it up when we get in the hospital setting, okay? So it's 2 to 4 mLs times kilograms times body surface area burned, right?
Yeah.
Rule of 9, right?
Okay.
So there's a couple things you need to know here, okay? Number 1 is, what is the rule of 9? Okay?
Did you advance it?
No, I'm going to take it. Okay? So with the rule of 9, Look, only Alan can judge me on this one,
But I know
because
one.
she's a good artist. I'm just, he's standing like I stand. Move to the side, because he got a gun on his hip. Alright? So when we talk about the rule of nines, what are we talking about?
The classification of our areas.
Right, so they basically break down the body into subsections, right?
Yeah.
So, somebody keep track of this. 9% on the head, right?
Yes.
Huh?
That's right. Yeah, that's
I
right.
like it when it's like broken down more.
Paramedic.
I get tripped up.
Like it's
18% for the front,
Or like for the arms and 9.5, you know.
Right.
4.5, you know, that's broken down.
9% for the arms,
mm-hmm.
9% there. You get 1% for the groin area, doesn't matter how big you are,
But then the leaders,
okay?
That's just the front.
put it up the way, put it on
And then, somebody adding this up?
Yeah, I got it right here. Yeah,
18 for the legs, right?
both legs.
So,
You
18,
gotta put it on 18 though, put it back.
this is the front.
That's the
You
front.
get 18 for the back,
So 9 and 18.
okay? And when they talk about the 1% for the hand, okay, they're not counting like the groin thing, okay? When they talk about the hand, that's the rule of palms, okay? 3, 4, 5, right? So when we talk about the 1% for the palm, this is approximately this area right here.
You said it includes the fingers though.
It does not include the fingers, it's palm.
I thought in the book it
Okay.
said it includes the fingers.
It doesn't, okay? It's just palm,
Yeah.
okay? It's just the palm of your hand,
Yeah.
okay? Because look how big your hand is, okay? It doubles the area,
Yeah.
okay? Can I fit 18 on here? Nah. Okay? But if it was just the palm, okay, I could get 18 on there. Okay? Even if you got small hands. By adding the fingers, you double the size of the palm. Okay? So when you talk about the rule for the palm, it's just the palm, not including the fingers. Okay?
So why are the feet included?
Huh?
So I wonder why the feet included in it.
What do you mean? The feet are included. It's part of the leg.
Part of it, okay. My bad.
Okay? So, 18, 18, 36.
100 and all.
Huh?
It's 100 and all.
It's 100 all total, right?
100.
So it came out right?
Yeah.
So 99 plus 1?
Uh-huh. 100.
Okay. Alright. So, Parkland Formula, we gotta figure out how much of the body surface is burned.
Okay.
Right? So if it's their whole right arm, right? Shoulder all the way down, 9%, right?
Okay.
If their whole right arm and just the front of their chest,
9.
okay,
18.
it'd be 27%,
Oh, 18.
right?
Yeah.
If it was their arm, their chest, and half their face on this side, okay, add another 4, 4.5 or 5,
Better 1.5.
right? So 27 plus 5, 32%, right? So if we're dealing with Parkland Formula for this patient, okay, with 32% body surface area, okay, we think about the high we just go with the high end of this, but you gotta be able to work it out for both, depending on your protocol, et cetera. Alright, or your test question may be Parkland Formula using the least amount of fluid. Okay? That's why you have to know the range. Okay? So using the most amount of fluid, 4 mLs, we know he's got how much? 32% burn. Okay? Now we have to know his weight. Okay? The patient weighs 220 pounds. How many kilograms is that?
110.
100.
Oh, we gotta break it down.
He already gave it to me.
Yeah.
Which is it?
It's 100.
100. I said 100.
No, you said 110. Alright, you just divided by 2, you forgot the other part.
Yeah.
And that's one of the numbers you were supposed to memorize. Okay? 220 pounds is 100 kilograms. Period.
Yeah.
Right.
Okay?
Yeah, absolutely right.
Alright, so 100 kilograms. 32, 12,800. Right? Okay? Now we're going to divide that by 2. 6, 4, 0.
Yep.
Right?
Yep.
6,400.
So,
We divided by 8.
so
Okay?
okay. Oh, okay.
So, on this, by the way this formula is set up, alright, we're going to give 6,400 mLs over the first 8 hours. 8 hours. 6,400 mLs over the next 16 hours for a total of 24 hours, right? Alright. So now,
Hold up. Hold.
go ahead.
That 32%.
That's 32. 32%.
Do we just take the percent off and use 32, or do we use 0.32? Just 32.
Just 32. Alright, so, Houston had this problem, the other day when we were talking. Alright? She was trying to multiply it by 32%. Okay? You don't multiply it by the percent, same way you don't multiply it by kg, you don't multiply it by ml. This drops off, and you just have the pure numbers. Okay? Because you can't factor in kgs versus mls versus percentages. They're not the same. You can't compare. Alright? So if you wanted to do it the long way, you'd have to set up the formula to cancel each one of those out. It's just easier just not to put them in. Okay, once you know what has to go in there.
Alright.
Okay? So we get rid of that, get rid of that, get rid of that. And it basically comes down to 4 times 100 times 32 divided by 2. Alright? So now that we got 6,400 mLs over the first 8 hours, okay, on the EMS side of the house, we need to figure out what are we going to give them in the first hour. Okay? So how do we get that?
Divide.
Alright? So we take 6,400 over 8 hours equals X over 1. Okay? Is the way you would set that up. Okay? So, it's the same thing as saying 8 hours equals 6,400 mLs. Right? So how do we get rid of that? We divide both sides by 8, divide this by 8, X equals 7, 8, right? 8 times 8 is 64, right?
Right.
So it'd be 800 mLs in 16 minutes. Okay? Notice I didn't write in 1 hour, because what's next? Now I have to figure out my drip rate, right? I have to figure out how I'm gonna give it to them in order to get that 800 mLs in 1 hour, okay?
Once we get to 6,400
Uh-huh,
for the 8 hours, why don't we take 60 and divide it by 604? And that would give you 106. Then you do, that's how much you
because
get.
that would give you the wrong answer.
I need a little bit more, like, I guess, why are we not using 60? After we already know the 8 hours, we wanna know within the first hour, which is 60 minutes.
Right, well, because you got, this breaks it down by an hour, right? It's in hours, okay? So if you wanted to get what it was in 1 hour,
Why would you?
you would have to divide this by 640 to get it in minutes. Or, I'm sorry, 480.
Yeah.
You have to divide by 480 to break it down into minutes.
Okay, it's 60.
Right,
Okay, thank you.
okay? So if you broke it down by 480, 6,400. What's 6,400 divided by 480, Ruth, on your calculator?
13.3.
13.3 mLs per minute. Okay, and if we do it this way, 800 divided by 60 is going to give me what?
13.3.
The exact same thing.
I'd rather do it slow.
Okay? So it works out the same, but and the reason we don't do it that way is because you would,
Because we did the 64 milliliters divided by the 8.
divided by 8. Okay? 640.
8 hours.
6,400 in 8 hours, right?
Mhm.
So if I want to break this down into minutes right here, okay, I have to know that 8 times 60 for minutes is 480, and then divide the 480 by this. Otherwise, I divide this by 8, that gives me 1 hour, and then I divide it by 60.
Okay.
You get to the same answer, but you have to know what you're doing. Okay? You have to know how you're breaking it down.
And I'm just assuming it's 480 seconds in a minute,
No,
in an hour. Like
There's 480 minutes in 8 hours.
Thank you.
Does that make sense now? Or you understand you picking up what I'm putting down? Okay? That's,
There's 480 minutes. in
yeah,
8
and that's, alright. So what's the first one?
10%. It's like 10 all the way to 90, and then it's 20 milliliters per kilogram.
Yeah, don't worry about the bottom. So 10, 20,
30.
30,
Yeah.
so they're nice and easy on you.
40.
Yeah, all the way up to 90.
50, 60, 70, and we'll just go to 80. Alright, what's the next column? Weight,
Yes.
over this way?
Yes.
No, no,
Yes.
well,
No. It's not down.
no.
It's just weight across, so it's
So
kilograms.
you have to have two axes in
Yeah.
order to have a table.
So it's 10 kilograms, 10
10
kilograms,
all the way up
10
to
all the way
100.
to 100.
yeah.
Kilograms.
gave us the index for 10.
Alright, this is kilograms,
Excuse me.
right? And this is 10 here?
No,
Uh,
no,
At
it's
the
at the
top.
top.
It's
It's
not,
right
right?
across, it's 20,
And?
30, 40,
Actually,
No,
start
this
at
is right
here.
here, yeah.
20.
20,
All the way to
100.
100.
30,
We could just do like up to 40, because we get the idea.
40,
20 and 30. And 80.
and 50.
Yeah.
Alright?
Yeah.
So,
I'm sorry, I'm holding it
so you're using,
not.
and this table is using the Parkland Formula and using the most fluid.
Yes.
Right?
Yes.
Alright. So if we go to the Parkland Formula, 10% of body surface area burned. Okay? Change kilograms. And we know this is 4 mL. right? Cause it says the most, alright? So 4 times 10 times 10 is 40, times 10 is 400, right? Then we have to divide that by 2, divide that by 2. That gives us 200 in the first 8 and 200 in 16. Now, to get the number that goes in here, you have to figure it out per an hour.
Okay.
So we have to take 200 divided by 8. 8 goes into 2 0 times. 8 goes into 20 2 times. Gives me 16. 4 with a 0. 8 into 40 is 5 times. So this should be 25.
Yes.
Is that right?
Yes.
Oh, I couldn't see which, I'm behind but, okay,
Do you see how I got that?
no,
Okay,
I'm
let's
sorry.
do another one. Watch this.
Can you do the 21?
Which one? Pick one.
You can
She
do
wanna
20.
do the 20 kilograms.
The one that with the input, so it's like 20.
Pick one that the answer is not in the book.
Right, that'll be
Yeah.
the
So
20.
the
20 by 20?
kilogram column.
Alright, so let's do 20 by 20. Okay? So, if I go by my Parkland formula, we're using the max. It's 4.
Right.
Alright? Parkland formula, we're using the max at 4.
I just wanted to
Times
use it.
20 kilograms.
Yeah. It says it on the table. It says it at the bottom.
It's 2 to 4.
Yeah, but it says, but continue reading.
It says various values range from 2 to 4.
Yeah, continue reading.
Continue reading what? That's the last word.
Values on the
Based on
table
the
are
high
based
end,
on the high end of
which
the
is
2 to
4.
4 range of the formula. So the high end is your 4 milliliters.
Oh, maybe I was.
Okay? So we're using the high end, that's 4 ml, 20 kilograms, 20% BSA. Right? Divide by 2. 4 times 20 is 80. 80 times 20 is what? 1600.
1600.
Right?
Yes.
Divide by 2. Alright? Equals 800. First 8. 800. Second 16. Okay? Now to get how much per an hour, which is the table is asking for, 800 divided by 8 is 100 ml in 60 minutes. Okay? So if I go to the 2020 chart here, it's 100.
Yes.
Does that make sense?